Fantastic. So we get to spend a few minutes together talking about Java. No, we won't actually spend a lot of time talking about Java. You know Java already. But we'll talk a little bit about Docker. We're going to talk a lot about Kubernetes. And we're going to spend a lot of time just talking about microservices in general. Because we fundamentally believe that the world of Java, Docker, and Kubernetes is what you will want to have in order to do awesome microservices architectures. So we're going to spend a lot of time on these categories. I actually have a lot of content in this session, a lot more than will fit in 50 minutes. So is it okay with you guys if I talk really fast? And then we'll try to get to, we have some really awesome demos if they work for me. I'm basically running an entire cloud on this laptop. I had about 20 different JVMs running. I just killed about 6 of them to kind of free up a little bit more memory. We'll see how this thing performs, though. So let's dive right in. We got a lot of good stuff to talk about. If you want a copy of this session, or sorry, copy of these slides, well, go back. You can also find, I try to make all my slides available on a bit.ly link, bit.ly java doc kube, K-U-B-E, is where the slides are. And of course, a lot of the demo instructions are at the MSA instructions link there. So just keep that in mind. But let's go ahead and get boogieing along. Okay. One key point to talk about right away is microprofile. We forgot to mention it in the keynote session yesterday. We were supposed to. We didn't get that far. We ran out of time. But microprofile is specifically an organization, right, a nonprofit organization, if you will, that's formed by a bunch of different vendors and different organizers who are trying to make Java EE and migrate Java EE into the world of microservices. So you'll specifically see like Red Hat there, the organization I work for. You also see IBM there, Webster at Liberty, Payara, Tommy Tribe. So the key application server vendors are all there, -1 at this point. But you'll notice the rest of us are all there participating together. They're having committee meetings. They're defining specifications and defining standards. And so that's what's specifically happening with microprofile. It hit 1.0 as of Java 1, and that was the objective. You're going to see them roll out in an agile kind of way about every 3 months with the next iteration of the specification. They're moving very, very rapidly, and the primary purpose is to inform the JCP. So you're going to see that iterating within the community. It's purely a community effort. You can go and vote for the specifications you want to see. You can go vote for the standards and the other aspects that you want to actually see show up in microprofile, and it'll keep on rolling out. So go to microprofile.io for more information. Now, this is, of course, MicroDuke that we invented specifically for Java 1. I did see Andre specifically had the MicroDuke hoodie on yesterday, so it might be if you were at Java 1, you might have got one of our cool MicroDuke t-shirts. But again, that's about microprofile. So we won't spend a lot more time on it than that. We'll keep moving here. If you go to developers.redhat.com, though, we have a free microservices book that specifically walks you through how to get started with Spring Boot, Drop Wizard, and Wildfly Swarm. And you'll see more about that in the presentation as we go. But there's a free ebook available to you at developers.redhat.com. We have changed the homepage since I took this screenshot, but you should see at the bottom someplace the free ebook for microservices. Now, Red Hat does a ton of things in open source land. We mentioned that in yesterday's session. We won't drill down on this too much, but we actually work with a lot of different technologies. I started with Red Hat when JBoss was acquired a decade ago, and I was historically always part of the JBoss team. And JBoss, of course, has Drools and JBPM. We have Camel, we have ActiveMQ, we have HornetQ. We have like 3 different message brokers. We, of course, have the traditional application server, now known as Wildfly in the upstream, but there's a ton of stuff happening in the JBoss universe and a ton of stuff happening in the Red Hat universe. So we just want to make you aware of that. Now let's talk briefly about microservices. It's fundamentally about agility. So there's going to be a lot of things in microservices land where you're going to tell this principle or aspect to your boss, to your architect, to someone else in your organization, and they're going to fundamentally say, oh, we can't do that here. We say no. And the weird part is, I know that most of you in the room right now are thinking, wait a second, we have to do microservices. The boss already said we must. I already know for my own resume purposes, I must do some microservices. I know, but once you understand fully what microservices bring to the table, somebody in your organization is going to say, hell no, not here. We'll talk more about that in a second. But the trump card, if that term means something, right? The ultimate goal is greater agility. So you will actually break all the rules for greater agility. If you don't want greater agility, don't go here. But you will break the rules for greater agility. So just keep that in mind. We'll see more about that. As I said, this is the Gartner hype cycle. Since I did not make note of them from a copyright standpoint, I repainted the line for myself. But this is a typical Gartner hype cycle. Microservices is at the peak of inflated expectations. It will go through the trough of disillusionment where we're like, God, that sucks. okay? We did this with SOA. We did this with big data. We did this with IoT. We're kind of doing it with IoT right now. We're going to do it with everything. It's going to go through, God, this microservices sucks. And then it comes out the other end where, we're just doing it. It's cool. We don't talk about it anymore. Think about it. We don't talk about Hadoop anymore. We just do it. So this is the world we're going to go through, and that's where microservices is right now. Now, let's go here. Let's talk quickly about your journey to microservices, because I do consider this to be fundamentally important. You need to first, in your organization, ensure that you have some form of self-service, on-demand, elastic infrastructure. What this means is, as a developer, and many of you here are developers, I assume, if you have to wait 3 weeks to get a new VM of a production-like environment because you have to file ticket after ticket after ticket, and the ops team is backlogged looking at all these tickets, and they eventually get to standing up your VM with the right version of Linux, with the right version of the JVM perhaps, maybe with the right database schema and the right database engine, and it takes 3 weeks, you need to fix that problem first. That's rule number one. Solve that problem. If as a developer you can't spin up new infrastructure in a few minutes, you've got a problem at this day and age. So now some of you are thinking, what, minutes? Exactly. A lot of shops are 3 weeks, 4 weeks, multiple tickets. If you can't do it in a few minutes, you got to fix that problem, okay? And you can do that this day. You can use any kind of cloud provider to solve that problem. You can put OpenStack on premise, or in our case, we'll show you how to do this with Kubernetes as an example, okay? So you want to reorg to DevOps, and this is super simple. If you live in a world of dev versus ops, where the developer actually says, hey, Mr. Operator, here's my crappy code, please run it, you got to fix that problem too. Operators are humans too. Keep that in mind. DBAs, while they look like space aliens, they're actually humans also. So you got to treat them well, and as a matter of fact, they're all part of the same team. And DevOps means we're all part of the same solution trying to solve a problem. So just keep that in mind. You got to think about the DevOps. You got to think about your automation. If you are writing, here, let's make it real simple. You remember back when we used to get the MSDN set of CDs that came in a big old box and had a binder this thick and had like 100, yeah, you remember the 100 CDs in there? And we used to sit there all day upgrading our BizTalk or SQL Server. We'd feed CDs for hours into our servers. Well, we don't do that anymore, right? Now we kind of wget, yum install, right? apt-get, right? We basically have solutions for that. Well, we even have better solutions now. We write scripts to install. So if it takes any time at all to install a new server, and you can't do it with a single command line script, you need to fix that problem first, okay? So think about that. You need to also think about what you're going to do with Linux containers at this point. That's basically Docker. We'll show you that. So one more thing here. If this thing would work, okay? CI/CD, continuous integration, continuous delivery. There's a lot to say. There's a whole 2-hour session on this one thing alone. But if you don't have great continuous integration already in play, and most of you actually do not, just because you have Jenkins doesn't mean you're doing continuous integration. The big rules of continuous integration are trunk is always deployable to production, and everyone checks in their trunk every day. And most people don't do those two things. All right, those are Jez Humble's rules for how to do continuous integration, the fellow who wrote the book. So that's his 2 rules. If you're not adhering to those 2 rules, you're actually not doing CI. You're just doing Jenkins something or other. So keep that in mind. So there's a lot of work to do there. But once you do all those awesome things, you're ready to build your first microservice. And here's the super cool thing. If you do all those other things first, your monoliths will also be super fast and super small, not just your microservices. And so there's specifically one organization that we worked with that actually took a 3-month deployment cycle time to 1 week, all by doing the first things. They didn't actually have to break up their monolith into individual microservices. They didn't have to do distributed computing. They didn't have to do all this crazy stuff with service discovery, service circuit breakers, and all that yet. They were able to take the one monolith, the one that they had, and move it into a 1-week deployment cycle by doing all these other things first. So I make that point, and I kind of make that point rather strenuously, because it's critical that you think about these other prerequisites, okay? Once you, of course, have your microservice, you're ready to be a unicorn, right? Okay, you guys saw this perhaps in the Vertex session, but a kind of different set of properties here. I use these images a lot. Let's keep moving along here. So I'm not the only person saying this. Martin Fowler's also said it. He specifically says you must be this tall before you can do microservices. And for those of you a lot of you folks are really tall. So you might be okay. In my case, I was the kid who couldn't ride the ride at the roller coaster park. I was too short. And I'd go up to the thing and say, come on, let me on. So I love that analogy that he uses. So it's the same kind of principle, though. Okay, we'll keep moving. We'll keep moving here. So let's talk about a monolithic system. So a monolithic system is so large that it takes so long to move through the deployment pipeline from development, from code change into production. Because it's so big, it takes so much amount of time. It's so big, it actually takes a whole lot of people to agree to work on that system and make a code change. We have to do a formal QA process. There's a compliance process, security review, all these things have to happen before it goes to production. And it might take 24 weeks, and that would be fast. Some organizations are more like 6 months. Some organizations are 9 months to production. The one organization I spoke about earlier was 3 months. They were moving pretty quick at 3 months to production, but when they got to 1 week, it was mind-blowing. They could actually react to business changes, security problems. They could react to critical competitive issues in 1 week increments versus 9 month increments or 3 month increments. But in the world of a 24-week deployment, that's about 8 3-week sprints. Most people do 3-week sprints. Most people will do about 6 to 8 3-week sprints, and then they deploy. At least that's what we've been finding when we ask people what they do. So that's pretty normal. But what you might do is once you introduce all these other aspects we mentioned earlier, you start thinking about continuous integration, continuous delivery, you start thinking about automated infrastructure, you do all your automated testing, you introduce Linux containers. You can shorten those intervals from 12 weeks, 9 weeks, 6 weeks, right? Even slower, or even faster, I mean. You can get down to zero downtime deployment strategies. I'll show you some of those. Edson actually talked about those in his session. I'll actually demo some of those myself. And you get to like a blue-green deployment or canary deployment, right? You can actually go super fast. Because now you're moving so fast, you're deploying all the time. You actually have to think through these kind of deployment strategies. Now, here's where it gets strange. Okay, you can see right here it says 3 weeks. This thing actually double clicks. Let's not use that anymore. So you go from 3 weeks down to 1 week increments. Now, this is where the magic happens. How can you go faster than a 3-week sprint cycle? This is where it gets kind of strange, okay? And now if you talk about the Phoenix Project, if you've not read this book, you must. And actually, there's a follow-on book now. And actually, there's 4 books that you should really all read. Lean Startup, Lean Enterprise, Phoenix Project. This is one I've read. You got to read it like every 6 months. It's actually really fun to read, so it's actually kind of good to read. It's like almost like a romance novel, okay? And then, and it's written in that way. It's all fiction. But then there's the DevOps Handbook that just shipped from Amazon in the last couple days. So I actually got mine and brought it on this trip with me. So make sure you get that book also. But they talk about 10 deploys per day in that book. How's that even possible? And you do that by breaking up this big old piece of code, right, into multiple individual code bases, and they have all their own independent sprint cycles. As a matter of fact, you might have patches to the operating system, patches to the JVM, and you can actually deploy those instantly without having to check any of the code because you have a nice automated testing suite for that. And that may sound kind of strange too, but there are literally people still living with heartbleed in production today, because they don't know if they can patch their Linux without destroying their application. And by the way, to patch their Linux, they have to reboot the server. They don't even know if the server will come back to life after reboot. Now, that may sound kind of crazy to some of you folks, but there's a lot of people living in that category. I won't ask you for a show of hands, because I know some of you are probably in the audience right now. Let's keep going. So these are the key microservices principles. We mentioned this in the Vertex session yesterday. Fundamentally, it's about deployment independence, but let's kind of focus on a couple of these others right here. These are the ones that break the bank. Decentralized governance, meaning each individual team responsible for their individual product, their individual microservice, is responsible for their customer, their SLAs, service level agreements, and they will determine when they go to production with their customer, right, based on business needs that they specifically have. They will determine their architecture, their infrastructure for that, and they're responsible, not some centralized enterprise architecture team who decides, nope, you're not allowed to move to Spring 4.x today. You're not allowed to move to WebSphere this or that. You're not allowed to move to WebLogic. Right? The people who say no can no longer say no. And that may sound kind of weird, but as developers, we're used to being told no. The DBA tells us no, we can't make that schema change. The operators tell us no, we can't actually use that version in production. The enterprise architecture team tells us no, we can't have this new thing like Spring Boot or Wildfly Swarm or something like that. And that goes away. Decentralized governance means each team is now responsible. You also have decentralized data management. In a microservices architecture, everybody has their own database. This is where, people's minds are blown in corporate enterprise IT. So if you work for a global 2000 company, these things are fundamentally hard in those big organizations. So just keep that in mind. And that's what I meant earlier when I said these are the things that people will just say, hell no, we're not doing it. But we'll keep moving because we got a lot to show you. These are key microservices concerns. I don't want to spend a lot of time on them, but you need to think through your load balancing, your discovery. So how does a service find another service? Resiliency. If that other service I'm dependent on dies and goes away, is my service still okay? That's where circuit breakers come in. We have a demo of that. There's also the concept of the API. You're married to your public API. It's just a standard REST API. Use JAX-RS, use Spring MVC. Is this thing kind of thumping, by the way? Seems to make a lot of noise. I hear some feedback. But just think of the API that you have to create, and then you would basically guarantee, as a product vendor, product creator, the microservices team, that you guarantee that API to be backward compatible. You also have to think through your invocation model. Am I making REST calls over HTTP? Am I using some form of messaging broker and infrastructure? Am I going to use Corba, for that matter? RMI over IOP? Because microservices does not dictate the invocation protocol. Your team does. Your organization does. Most people are using REST over HTTP. There's also the concept of distributed tracing. We have an example of that in the demo, so we'll get back to that in a second. You have to think through your build and deployment pipeline. What is your authentication mechanism? Are you going to use some form of SAML token and other mechanisms, right, to make the invocation across all these different services? You got to think through your distributed monitoring, because if you don't have great monitoring and great distributed logging, don't go here yet. You got to solve that problem first, because if you don't have great monitoring, great logging, and distributed tracing, you're just going to screw everything up and actually suffer a lot of pain. But some of us like pain. Might be good, okay? So at a high level, from a Java perspective, right, we said we were going to talk about Java, Docker, and Kubernetes. These are the stacks that people are using on a regular basis. So DropWizard was kind of the first to do the concept of, I'm going to do a JAX-RS RESTful endpoint in Java. I'm going to bundle that into a fat jar and distribute that jar as a self-executable. So they were kind of the first to really do this sort of thing. The Spring Boot team got it started as a web application stack, and then they actually migrated to doing microservice architecture also. And so they've definitely been one of the most popular ones out there. And we also have Wildfly Swarm, which is based on our Wildfly application server. So if you want pure Java EE, you can live in the Wildfly Swarm world, right? You can also do Spring there too. Then of course you have the Spring MVC kind of model within the Spring Boot, and DropWizard was one of the originals. Anyone here using DropWizard at this point? Couple? Okay, fantastic. They were one of the first to get in this space, so a lot of people, but we forget about that. We're like, no, it's Spring Boot. They invented it. No, it was DropWizard. They got there first. And a lot of other people do this. Then I also talked to you about Vertex. We did this session already on Vertex specifically, but there was a demo I didn't show you with Vertex. So I want to actually show you a demo of Vertex, just because if it runs, it's super awesome. It might also kill my machine, but we got to go for it. Vertex, of course, is a reactive toolkit. You embed it in your application. You can do virtually anything you want with it. Yeah, let's do this here. Let's get my Vertex server stood up. And then I'm going to run 2 client-side AngularJS applications. Uses Node to launch the AngularJS application. But if this goes OK, it'll be super neat. All right, looks like it's coming to life. Fantastic. Coming to life, and let's do a refresh. This is a demo we actually built for our keynote presentation last year. And let's refresh that one. So I basically have a Safari, a Chrome, and another Safari running here. Oh, I forgot my password. I have it in a notepad. This is what you don't do with a password, but that's okay. All right, here. Yep, there it is. It's all running on my machine, so even if you saw the password, it wouldn't matter at this point. All right, so there we go. All right, so watch this. Let's see if we can make this work. So my Vertex is running here in the background. There we go. So Vertex is running in the background. It's basically, as I mentioned yesterday, it's specifically a reactive toolkit. It can do anything over any port. And one of the things you primarily do with it is build these highly interactive applications. So you don't worry about get, click, post, submit, right? Wait, chunk, back. This goes well beyond Ajax, okay, if you know what I mean. So let's give it a try. Let's start our game. There we go. So now, watch what happens. Every balloon click, if I can hit it, is in fact a transaction back to the back end. You can see it actually reflecting on the back end. And it's actually kind of a hard game to play. And what's happening on the back end is it's literally making calculations based on this. We actually ran this for 800 individuals. We put in tens of thousands of transactions in like a 60-second window. We ran it live with a bunch of people. I'm running this on my laptop. But it's actually kind of hard to play. So here, watch this. This is fun. I want to make it fatter and slower. And then let's make it a nice green background update. Boom. Oh, I actually hit yellow. I wanted green. I said green, make it green. There we go. So real-time updates. Now I can hit these balloons, okay? And now you can see my transactions flying through the back end on the back end server. And we actually had the back end transactions flowing through several different microservices across multiple application servers and multiple engines and things like that. And Vertex was the front end for all of that. But one last trick I'll show you, if I can see it. Where is it? Aha, there we go. Watch this. They did this. These are the people who did the game with me. They're like, OK, Burr, we're going to add you to the game. Let's see here. There we go. So, and there we go. There's my, yep. And you can do a real-time pause. Let's see here. Oh. Freeze the game. So we did that with hundreds of concurrent users, all sitting in an audience like this, with real-time interactions, just like you saw there. And that's what Vertex can do, okay? So that's why I'm so excited about Vertex and why I think it's a lot of fun, because it doesn't take a lot of code to do that stuff. You saw the finger painting thing I did yesterday that took almost no lines of code. So there's some really great things you can do with it, but that's enough about Vertex for now. This is not a Vertex session, but we'll get back into it, okay? So on that note of just microservices in general, let me show you one other thing. Let's see if this works for me. Let's get over here. So if, in fact, you've done some Spring Boot stuff, you've seen start.spring.io. I can come in here and call this the JavaDay demo, and I can say I want web, and I want the actuator. Dun, 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 dun. I want JPA, I want security, etc. I can say generate project, and it gives me a default project with a default POM XML. I load up my code, and I'm ready to go. We also have Wildfly Swarm. Same kind of idea there. I can call this the JavaDay 2 demo. Same idea here. In this case, I'll just say JaxRS, because since it's Java E based, that's all you really need. Do the same thing. I can hit generate project. Notice it does a download right there. Oh, I guess that's kind of small. See, it downloaded my projects right there. Okay? So I can go into my downloads folder. I actually have it open already. Okay, and I can do an unzip. JavaDay 2 demo. Okay, all right. JavaDay 2. There we go. So there's that project. Let me raise this up so you can see it a little bit better. I can do a Maven clean package. Let's see if my network is strong enough to give me a Maven build. Fantastic. Okay. Let's actually bring up Finder here if we can. Yeah, let's just go to downloads. There it is. Okay. No, there's a target now. There's my Wildfly Swarm jar. So that's my fat jar. So basically, that's a self-executing jar, and it's ready to run. I've built my application. So I can go, in this case, we have a default endpoint. So I'm going to say java-jar target. And then, what was that thing called again? Demo swarm, right? Let's see if this works. All right, there it goes. It gets loaded up. And if I did all that correctly, I can go to localhost, and I believe the default endpoint is just hello. There we go. All right, so that's what that looks like. All right. So we have a microservice. We could do it with Spring Boot. We could do it with Drop Wizard, which is just a Maven archetype. We could do it with Vertex, like I showed you earlier. We could do it with Wildfly Swarm. That's not the hard part. The hard part is now how do you run this at scale in a production-like environment, and that's really what the rest of the session's about. So we'll keep moving along here, okay? Let's jump back into slide mode, right? You will see a circuit breaker in a second. But we specifically, in this demonstration, use Netflix OSS because it's actually pretty awesome. And you can use Netflix circuit Hystrix to not only invoke other external services like through a REST endpoint, it'll work across numerous types of protocols. So like people use this for their JDBC invocations also, which is pretty wild if you think about it. You have to basically decide that if I'm going to invoke a remote anything, and JDBC actually is one of those things, I may, in fact, break because the other guy breaks. And your circuit breaker makes sure that you don't actually all die together. Okay, we'll show you an example of that in the demonstration to kind of make it more clear. But this is the Hystrix dashboard. We'll show you that also. Give you some nice statistics around when the circuit breakers are breaking, open, when they're bouncing off, things like that. We'll show you that. Zipkin is also in our demo. We'll show you that in a second. And all this, by the way, is running on what we call the Container Development Kit, which you can download from developers.red.com. It's basically a Red Hat Enterprise Linux environment all running here locally. Okay. Let's talk about Docker real quickly, and we'll jump right into the demo side of things. So as a Java developer, if you've been doing Java long enough, you probably actually build your applications on a Windows desktop, That's what most Java developers do, and I have survey data to prove that. So it's literally 80% of our market is still Windows desktop. Many of you are still on Windows. But you deploy now not to Unix any longer like you used to. You used to deploy to Solaris. You used to deploy to AIX. Now most of you deploy to Linux of some sort, right? It may not be Red Hat's Linux, but some Linux. And that slash thing will bite you in the butt, okay? It's happened many times. How many people has that happened to in here already? All right, a lot of you. So I'm not kidding about this, right? So that concept is just a stupid slash because you're opening a file on the file system, burned, right? Works great on Windows, dies on Linux. So that's one problem. Also, if you look at your JDBC driver, I've seen many people burn with this also. Like I have a certain JDBC driver I'm connecting with here to my local SQL server, Oracle database, DB2, whatever, but it's not the exact same driver we use in production. And therefore, things don't quite work, okay? So this happens time and time again to a Java developer. And this is what Docker is trying to solve. So let's kind of jump right into it, okay? So if you think of your application stack, you put your code on top of, let's say, an application server configured a certain way. If you can see here that I have a certain JDBC driver, a certain data source, certain JMS queues or topics that I want predefined. I know I want this version of WebLogic, this version of Tomcat, this version of WebSphere, all that's defined, right? I have it set up here on my Windows machine. I have a certain version of Java that I have to use for my corporation. We're all on Java 6 here at my company. And then, of course, I have a certain operating system this runs on. That's your stack. And your application has to have that stack 100% right, so that you can have 100% confidence that your bugs are still your bugs, right? Because think about that. Sometimes you don't know if it's your bug in your code or some crappy thing underneath you that actually blew up on you. How often does that happen? It happens all the time. So the stack is super important. And more importantly, we as developers have to be accountable. We can't just take this thing that we manufactured on our Windows desktop and whip it over the wall to the poor operating person, and it hits them in the head, knocks them out, and they stay up all Friday night, all Saturday, all day Sunday to get it running by Monday. We can no longer have that. And the way we solve that problem is specific. Oh, we actually have one more slide. How do you actually do that today? This is actually really funny. How do you throw your WAR file, your EAR file over to the operator, and you send them an email with what your requirements are, assuming you remember to type everything in that email. And you assume that the QA person who's actually going to test it before it goes to production even understands the email to get the right version of the JDBC driver, to get the right version of the data source configured correctly, the right version of the app server. And this is what we do. And if you're super cool, you actually have a wiki instead. But think about that for a second, okay? So if I'm on a Windows desktop and here's my environment, here's what it looks like in production, they don't match at all. So how do I get a production-like environment as soon as I possibly can to do the job that I need to do? And this is where Docker comes into play. So inside the Docker file, you will specify the version of operating system and the app server that you want and the JVM configuration that you need. You'll configure the app server the way you need it to be configured with the right JDBC drivers and all that. And then, of course, you'll put your WAR file inside it. So that, while it seems trivial, it's like magic because it ensures that you have the right stack underneath your code. And more importantly, you, the QA people, the compliance people, the ops people, all agree on what the stack really has to be. And the most awesome thing is you can run production-like environments on your laptop. Now, most of you probably already know Docker already or at least played around with it, so I won't spend a lot of time on it. But let's just kind of hop into a command line real quick. Let's see if this works for me. Boom, 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 right? So it's just simple commands. I can do Docker images, and you can see I have a ton of Docker images here. Let me make this window a little bit bigger. Hey, I said bigger, not smaller. Oh, Lord, it's not going to let me stretch out that window. This is what happens when you hook up with a projector. It kind of freaks things out a little bit. There we go. All right, so Docker PS. I'm running a lot of stuff right now, okay? So I'm running a lot of containers. I got a lot of images loaded. And we can spend a lot of time working on it, but you can do a Docker build, Docker run. Basically, you create your Docker files, and you're ready to go. If you look at our application projects, let's see if I can open it up real quick. Here's what a Docker file might look like. Okay, and this is a Spring Boot application. So we're specifically using the Fabric 8, Java 8 JVM-based environment. We're setting certain environment variables. We're exposing that on port 8080. And the cool thing is, because I'm running with Kubernetes and OpenShift, everything runs on 8080 in this environment. I used to have about 20 different Java services all running on 8080. I had to kill a few of them because I was running out of memory. So I'm still at probably 12 JVMs running right now. Okay, so that's what the magic of Docker does for you. We'll keep going, though, because most people here probably know something about Docker already. But you'll see more of this in action as we get into the demo mode. So let's talk quickly about Kubernetes. So Google came to us a couple years ago and said, hey, we're about to do this really awesome thing. We're like, what? Well, you know those Linux containers everyone's excited about? Yeah, we like Linux containers too at Red Hat. Well, we launch 2 billion containers a week here at Google. We know something about containers. As a matter of fact, we want to open source our infrastructure. You want to participate in that? And we were like, hell yes, we're on board. So we got on board with the Kubernetes train right from the very get-go. We were an early contributor to the project, and we're actually the second largest contributor to the project outside of Google. We're also the second largest contributor to Docker, outside of Docker. So Kubernetes is specifically what you will see inside, well, you actually don't see it, they see it. So it came from the roots of Borg, was the original project that they created to launch 2 billion containers a week. So we're talking Google Maps, Gmail, we're talking Google scale. So I doubt you guys have to launch 2 billion containers a week. Maybe you have to do a couple hundred, though, okay? Or maybe 20. But that's why we chose Kubernetes as our underlying infrastructure. And so we did that with Google in partnership. At a highest level, you will see the concept of a master node and then individual worker nodes, if you will. So the master is basically the orchestrator, the scheduler. It also is the API to interact with a Kubernetes cluster. And then you will see machine 1, machine 2, machine 3, which might be virtual machines. They might be virtual machines running on Azure or Google or Amazon. They might be virtual machines running on OpenStack, right? They're just virtual machines. Or they could be physical machines also. In my case, I'm literally running it all here on this laptop, okay? We'll keep going. There's some key concepts in Kubernetes that you'll have to get your head around. And this is one of the challenges with Kubernetes, is it has a learning curve associated with it. But once you get your head around it, it is magical, and we'll hopefully show you that in the demonstration, make some sense there. But it has this concept of pods. You can mentally map a pod to a container, okay? And you can kind of map a container to a JVM, is how I like to think of it. It's just what my stuff runs in, okay? It has, in the case of the container, it's Linux and the JVM. In the case of the pod, it's like a container, but you can actually have 2 or more containers if you wish to in a pod. So the pod, if you don't know the term pod, it actually is a family of whales or family of dolphins. That's where it comes from. So the Docker emblem is a whale, and you can have 2 whales together, right? That's why they call it pod. A lot of people don't know that, by the way, so I meant that point. So 1 or more containers in a pod. They share an IP address, they share storage, they share life cycle. So when you kill the pod, all the services die. When you bring the pod to life, all the services come to life. They share the same IP address. Essentially, that means that you have to have multiple ports identified. But if you only put 1 container in the pod, it can all be on 8080, all right? So I'm running everything on 8080 here, like normal. Okay, so just keep that in mind. So shared lifecycle is super critical. You also have the concept of the replication controller. Now they call it a deployment. Well, there is now a deployment that we helped build with Google. But the concept of replication controller is just a service that says how many of these things need to be running at any given time. And for some reason, if in fact somebody dies somewhere, some JVM runs out of memory and its container goes belly up and dies, then in fact Kubernetes will say, oh, bring a new one to life over here, bring a new one to life over there, as an example. So there's also the concept of the service. You'll see here, the service is an exposed endpoint within the cluster. By default, it's within the cluster, and you have to have some form of external router or load balancer to interact with that internal service. You'll see an example, though, where we in OpenShift have added the router layer in addition to having that service layer. And then, of course, the concept of labels. So the labels are super critical because you can then basically say, here's my service. It's microservice 1. It basically is microservice 1 could be its name. It's version 2.0, let's say, and these are just name value pairs of labels. It's the one for development, not for QA. So you literally can have one cluster that's pre-production that has dev, QA, load testing, security compliance, et cetera, all in one cluster, but label it appropriately, and therefore you can actually interact with those pods any way you would like. And it's super cool to actually do the labeling concept, so we won't belabor that point in a big way, but you'll see some of that. Okay, the pod is the group of whales. We mentioned that already. Now, here's where it gets a little bit more interesting. Within OpenShift, we've added some capability to it. We have a specific set of development tools. You can integrate with CI/CD, Jenkins specifically. I have a Jenkins demo. We won't have time to run it here, I don't believe. But you basically have all these tools for ops and devs that interact with the cluster. We've extended the Kubernetes API server to have this concept of deployments, though that has actually made it to the upstream now. We also have the concept of image streams and a build cycle. But all these things tend to flow back into Kubernetes proper over time. And we specifically added this concept of the routing layer. So if you look at it like this, well, you can see here I have a Spring-based microservice running here. I have Wildfly running there. I have Postgres. I have Tomcat, MySQL. There's even a PHP myadmin there, and that's an example where we have a pod with 2 containers inside it because PHP myadmin needs to stay with its MySQL database in this case. And so what happens is, and you can see I highlight in red here specifically what is OpenShift specific. But if one of these nodes dies, let's say it literally loses its network connection, someone pulls the power plug on it, it physically dies, as an example, Kubernetes will reschedule those pods, those containers, to other available resources. So that concept is incredibly important. You don't have to worry about it. You can just let Kubernetes manage it, okay? So let's show you the demo. The demo makes a lot this more clear. If we can get it all running well, let's try it out. Okay, so I'm running the Hystrix monitor over here. Let's do a refresh on it, make sure it's happy. I'm running my main console, wherever I went. We don't care about that one anymore. Did I kill that one? Let's make sure we shut that guy down. Yep. All right. And let's go over here. Don't need any more memory being used if I can avoid it. And not that window. This is the problem with having too many windows open. There. Okay. All right. So here we go. So this is the OpenShift console. I could show you a lot of different, command line tools. And actually, if you want to do that real quick, where'd my command line go? Is that it? Okay. So kube, CTL, get pods. So much like you can do a Docker images, Docker PS, say all that, you have kubectl commands to interact with a Kubernetes cluster. But you don't have to use the kubectl commands. We basically have an OC command line, but we also have this nice console. So these are all the microservices I'm actually running. Let's kind of walk through them real quickly. Okay? We have the different patterns. I mentioned this in the session yesterday. So basically, I have my browser as the aggregator. The browser is making invocations to those server-side services, and the browser has the JavaScript-based business logic to aggregate the results into the user interface. That's a very common pattern to see in a microservices architecture. A lot of retailers do it this way. If I come over to API Gateway, this is more what Netflix will do. You can see that the server-side code, in this case it's a Spring Boot-based API gateway, is then invoking Wildfly Swarm, it's invoking another Spring Boot application, it's invoking a Node.js application, and a Vertex application. So you can use, again, each microservice team can use the tool that they wish to use. That's kind of the idea. I would not encourage you to get too crazy with that idea. But we kind of wanted to show that example here. And this is an example of the chaining, right? So in this case, we have the browser is calling Ola, which is calling Ola. They sound a lot alike, I know. I have people on my team that speak Portuguese, so they thought that was interesting. Aloha, because I'm from Hawaii, so that's why we got that on Vertex. And then bonjour for Node.js. So we go over here, okay? Let's play with this thing a little bit. We can also, let's do this. Okay, there's bonjour. It all looks good. Notice the circuit is closed for bonjour. Okay, keep your eye on that. We're going to come back to that. So the circuit is closed. That means everything is working. Okay, let's kill bonjour. Where'd it go? Oh, I got 3 of them running right now, and actually that's a good point. Let's make that point real quick. If I go back over here, if you notice, it's actually, if we watch closely, it's actually returning, that's actually the host name that it's returning in that string. So bonjour literally thinks it's running on 3 physical servers right now. That's the cool thing about this Kubernetes Docker-based environment. It doesn't know it's running on a little bitty Docker container all on the same laptop. Okay, so let's kill it. Let's run it down to 0. It's going to give me a warning because you just turned off all instances of that. Okay, yep, it's dead now. Let's go back over here and back over here. And let's get these things side by side because this will be important that you kind of see these things. Okay, all right, let's click. Watch what happens. All right, notice the 1 there? There's a 1 timeout. And if you notice, bonjour has this fallback response. So the system is not dying. It's just giving you a default response when a response is not available. Let me go back over here, click, click. You should see 2, there we go. So 2 timed out requests because this thing is failing. Watch what happens if I kind of really bang on it. You gotta get about 5 in a row. Watch what happens. Boom, we're open. So now we're gonna bounce off faster. Because here's the idea of a circuit breaker. If the other guy is dead, stop kicking him. But this is what we do as developers. Because think about what our users do and think about what we do as users. If the website is kind of slow, what do? Refresh, refresh, refresh. And guess what we've now done? 3 new connections, 3 new requests. This thing's all backlogged, and it's actually trying to respond to the original request. So the idea of the circuit breaker is if you have service A calling service B, it's like, okay, he's dead. Stop kicking him. Stop hitting him. And you're going to bounce off. okay? And then if you notice, every now and then you'll see it take a little long because it's trying. Are you alive yet? No, still dead. Okay, bounce off, bounce off, bounce off. Are you alive yet? Nope, still dead, bounce off. So it just keeps on going like this till the system gets, kind of gets back to normal. So let's say the other team does bring their system back online. We'll just bring it up to a couple here again. Okay, so they're bringing their service back up. That other team is now trying to heal their environment. And there we go, we got a blue ring, so that means we're back up. So let's go here again, watch what happens. Circuit is closed, we're back to good. All right, so that's the idea of Hystrix. And you can use this for any kind of invocation from HTTP to HTTP kind of thing, or even a JWT driver, or you could write your own. It's nothing more than a thread pool. That's really what the magic is. And it's done in an asynchronous way so that the request coming in doesn't get blocked on the request going out. And it's kind of a simple concept, but they've done a great job with it, and this is part of how Netflix operates as an example. So that's the concept of a circuit breaker. Let's show you a couple more things in here, okay? Let's show you our API gateway. Notice I have the green version of this API gateway running. Let's actually come over here and go down to API gateway. Well, let's just search for it. Okay, there's the API gateway. And you can see that I basically have a pod running of blue and a pod running of green. So the idea of blue-green is you have duplicate infrastructure all running, and that way you can fail back and forth. So let's see if we can make some of that work. Okay, let's do this. We were going to run out of time, but let's keep going here. Dun, dun, dun. Where is that one? Oh, yeah, this one right here. Okay, API controller. Let's make this, it says blue, let's make this JavaDay. Okay, let me come over here. I just changed the code. It's the standard Spring Boot application, right? So nothing funny there. Clean, compile. I like spelling it out. Makes me feel better. Okay, we're doing a Maven package. That produces our fat jar in the target directory. So that's target, okay? And then we just simply run our Docker build, and we have a very special Docker build that not only does the Docker build, it also instructs Kubernetes and OpenShift to reload that image through the registry. So it's going to do its Docker build. And if we actually watch over here, this actually takes a fair moment because I'm running out of resources. We'll see what happens here. See that Docker build's happening? And if I can even view it here in the log too. So that's my Docker build running right now. It's rebuilding that image based on the Java change I just made and loading it into the system. And then when it gets done, I go back over here. You'll see it redeploy, and there it goes. I caught it in the middle of redeployment. But this is what's important. I'm redeploying blue. I'm not injuring anything else. So let's go over here. Nope, wrong window. You'd think I would just do this a little bit better. There we go, right. Okay, so let's pull that endpoint. Notice it still says green because we're still hitting green. Even though it went through that whole build cycle, and everything was being redeployed, we're still there, all right? Green is running, and if I go back to my user interface, dun, 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 that one, see it says green. All right, let's update the route to blue. I have that hopefully still cached, there we go. Let's make sure you can see this, boom, boom, blue. Boom, we're at JavaDay now. We just switched to blue. Okay, wait, and you might be going, oh, we don't want that change in production. Okay, switch it back. Back to green. So that concept of having, if you're going to do multiple deploys per day, or you're even going so fast as a deploy every week, you actually can't afford to do all the QA cycles you normally do. And you can still have brilliant automated testing, don't get me wrong there, but you actually are going to do some testing in production by doing a blue-green deployment. Roll it out. Ooh, not quite right. Now, in this case, we rolled out to everybody. That's what blue-green is. It goes to everybody. What if you want to make it a little bit smarter? Okay, let me show you that one real quick. So I also have the concept of bonjour here. Let's go to 3. I guess I didn't click that button. Let's go to 3 of those. And I'm going to open this guy up here so you can see what the code looks like. And we won't make a code change, but you at least can see it. And this is the Node.js service as an example. See, it says canary there. So basically, we have 2 versions of it in production. We have the old one that you've been interacting with and seeing. Bonjour. All right, so there's my canary. Or sorry, that's not the canary. But watch what happens here. Let's do this, making sure you can see this. Let's go to 1. So I can try that new version in production just for a subset of users, a small group of users, and then what we're doing is, since we're doing the load balancing across it, you'll see that once it comes online, 1 hit is for canary. one of 3 hits by default. That's kind of how the algorithm's set up. You can make this more tricky than that, but if I now want to go to like 2 hits, all right, and drop that down to 2, it should be 50-50. And the cool thing about that is, again, I'm rolling it out to a subset of production. If I decide, oh crap, that's not what I wanted, I can roll this back up and roll this back down to 0. I can roll it out. So this is the kind of power that you get with a Kubernetes environment, with a Docker environment, okay? And let's see. My machine's CPU is going off the charts, but there we go. We're back to all bonjour all the time. Right, so this is what you get in a Kubernetes environment. But this is why I believe it's so powerful and what you want to have for a microservices architecture. Because you can now deploy super fast production. That's the whole purpose of choosing this architecture. And you're safe once you deploy. Okay? There's a lot more we could take you through, but we don't have a lot of time. But CI/CD kind of things. But let's jump back into slide mode. Make sure we cover the high points. Okay, so that demo, by the way, is available at MSA Instructions, as we mentioned earlier. There's also recorded YouTube videos. These slides are available to you. Just keep that in mind. One thing I would encourage you to think about, though, is you can have a fast monolith, okay? You don't have to break it up into all these individual services and have all that complexity. You don't have to have all the circuit breakers and everything else and the distributed tracing. You can just stick with your existing Java EE monolith and do all the other things, including running Kubernetes and Docker and everything else, do blue-green deployments, canary deployments, and you still get all that benefit. You don't have to break it up until you actually want to break into like multiple deploys per day, as an example. And so I'm not just saying that. This fellow named David Hannemeyer Hansen, if that's how you say his name, the guy who did Ruby on Rails, he wrote a great blog post on this concept. His organization, Basecamp, 37 Signals in Basecamp, they deploy once a week. That's as fast as he wants to go, okay? Same thing. Martin Fowler's also written about this. If you decide to go directly to microservices, there be dragons. It's kind of his thing on that, so you can look that up, Monolith First. There's also a great book that introduces us to circuit breakers. It's called Release It. I noticed some of the folks over here in the expo area had a copy of the book. I encourage you to check that out. It's an old book now, but this is where we learned about circuit breakers. And I'll show you my last slide because we're running out of time. I have a whole thing on the strangler pattern and things like that, but we could keep going. Let's just go here. So if you want to copy these slides, go to, find me on Twitter, @Burr Sutter, and then we can interact that way. You can also email me. Go to developers.red.com to download all this technology. Go to bit.ly, java.cube for these slides. And of course, you have access to the slides. You can actually file save them. They're all source available to you in Google Docs. And you can present the same presentation to all your friends and family. Because your children are going to be like, wow, Dad, blue-green. Hey, Mom, show me that canary deployment again. But seriously, if you want to do this, we have tried to document it all so you can actually run these demos for yourself on your laptop. You can run all these slides for yourself, and that was our purpose. I thank you all so much. I'm super excited to be here in the Ukraine. I've never been here before. If you guys want to find me on Twitter. And if you have any questions, we'll see you after this.